So now let's say you have a bank ABC providing you FD at 10% compounded quarterly, 10% annual rate. This is the annual rate, compounded quarterly, they are saying. Okay, and you have, let's say, $500 with you. Okay, now the tenure of the investment, let's say, is 3 years. Okay, now the question is, what is going to be the future value of this investment? Same as that, right? Now how do you find this out? So here the key thing is 10% annual rate compounded quarterly. What does this mean? This basically means that the compounding will happen 4 times every year. Right, friends? So how do you calculate this? To calculate this, what you do is you divide 10% by 4. You add 1 to it and you raise this entire value by the number of years multiplied by the number of periods the compounding is going to happen. So this is equal to 1.025 raised to the power of 12. So the future value becomes FV is equal to 500 multiplied by 1 plus 0.10, which is nothing but 10%, divided by 4. This expression, this second expression, raised to the power of 4 into 3, or 500 multiplied by 1.025 raised to the power of 12. The value is equal to $672.44. This is the final answer, friends. Now if you want to generalize this formula, it becomes, there are n periods and the rate R is compounded m times, small m times, every period. This m here is called periodicity, right? So in this kind of a scenario, m is the periodicity, n is the number of periods, R is the compounding rate. FV here will be calculated as FV is equal to PV multiplied by 1 plus R by the periodicity, this expression, raised to the power of n into m. Let's do another example, friends. We will understand it better. Let's say there is a bank XYZ which is providing FD for 5 years at the rate of 8% compounded monthly, 8% annual rate compounded monthly, right? If you invest $1,000 here, that is $1,000 is your present value or present amount, then what is your future value? This is the question, right? This is the question. Now how do we solve it? FV is equal to present value or $1,000 multiplied by 1 plus the annual rate, which is 0.08 or 8%, divided by the periodicity. Periodicity here is monthly, which means we divide by 12. This expression raised to the power of 5 into 12. 5 is the number of years or number of periods multiplied by the periodicity. So this value will become, you can easily calculate it, friends, 1489.8. So your FD after 5 years, its value will become $1489.8 approximately. So this is the way you do the calculations. Now we have done quarterly, we have done monthly. We can make it more refined, right? We can make it daily. We can also make it continuously. What will happen if we make it continuously? Let's see that. The question is, your bank ABC gives you a 3-year FD at 10% compounded continuously. If you invest $2,000 in this kind of an FD, 3-year FD, compounded continuously at 10%, what is going to be your future value of investment, right? So the calculation here is going to be done through exponential equation. So in case of continuous compounding, the expression of FV, future value, is given by PV multiplied by E, exponential, raised to the power of R into the number of periods. So FV here becomes equal to 2000 multiplied by E to the power 0.1 into 3, right? Let's see what the value is. So this is equal to 2000 multiplied by 1.3498. This is equal to 2699.7. Right, friends? So in case of periodicity, what can happen? We can compound annually. We can compound half yearly. We can compound quarterly. We can compound monthly. We can compound daily. We can compound continuously. And one very, very key insight I want to mention here is, if the compounding is continuous, then the end value or the future value will be greater than the daily compounding value for the same initial investment. And if the compounding is daily, it will be greater than the monthly compounding future value for the same initial investment. If the compounding is monthly, then the future value will be greater than the quarterly compounded future value. And same it goes. Quarterly will be greater than half yearly will be greater than annually. If you want to verify, we can verify with this example itself. So let's do it, friends. Case 1. Continuously compounded at 10%. The value comes to be $2699.7, right? Initial investment was $2,000. Case 2. Let's do a daily compounding. Daily compounding at 10% only. Now, let us consider that there are no holidays in the bank. Every day is working, so compounding is happening every day. So what will be the calculation, friends? Future value will be equal to 2000 multiplied by 1 plus 10%. 10% or 0.10 divided by 365 to the power of number of periods, which is 3, into periodicity, which is 365. Let's calculate the value here, friends. So this is equal to 2000 multiplied by 1.3498. This is equal to 2699.6. So 2699.6 is obviously less than 2699.7, right, friends? Very close, but still less. Now let's see what happens when you do a monthly compounding. So case 3, monthly compounding at 10%. Here the future value will be given by FV is equal to 2000 multiplied by 1 plus 0.10, which is 10%, divided by the periodicity, which is 12, to the power of 3 into 12, which is 36, you can write, right? So let us again calculate this. This is coming to be 2000 multiplied by 1.3481. This is equal to 2696.36. Now 2696.36 is obviously less than 2699.6. Now we'll do case 4, which is quarterly compounding. Quarterly compounding at 10%. Here again the future value, let us write this. FV is equal to 2000 multiplied by 1 plus 0.10 by quarterly periodicity, so which is 4, and raised to the power 3 into 4, which is 12. This is equal to, again let us calculate the value, 1.025 to the power 12. This is 2000 into 1.3448, and the value will be equal to 2689.7. 2689.7 is less than 2696.36, friends. Now we'll go into case 5, which is half yearly compounding. Half yearly compounding at 10%. Here again the FV will be equal to 2000 multiplied by 1 plus 0.10 by 2. Because periodicity is half yearly, we divide by 2. And raised to the power 3 into 2, which is 6. So this is equal to 1.05 to the power 6. 2000 into 1.34. This is equal to 2680.2 approximately. 2680.2 approximately. So 2680 is obviously less than 2689, friends. So we are seeing as the periodicity, the periodicity is decreasing, the future value is also going down. So if the periodicity is continuous, the value is highest. If it is daily, it comes down a little bit. If it is monthly, it comes down further. If it is quarterly, it even comes down further. Then half yearly, again, little more reduction. Now let's see what happens if we do just pure annual compounding, no periodicity. So case 6, annual compounding at 10%. Here the future value is equal to 2000 multiplied by 1.10 raised to the power of 3. Because periodicity here is basically 1. So 0.10 by 1 is 0.10. So we write 1.10, and 3 into 1 is 1. And 3 into 1 is 3. So we keep it 3 here. So what is the value here, friends? 1.10 raised to the power of 3 is 1.331. So this is 2000 into 1.331. Here the value is 2662. 2662. This is the final answer, friends, for annual compounding. And you can see here clearly 2662 is less than 2680. So as the periodicity is going down, the value or the future value is going down. So this is one insight I wanted to share with you from this example.